Here's a real quick introduction to 3D graphing to get us going, and also a test of a different video capture system. We'll see how it works. So with 3 dimensions, let's first look at plotting points. I just wanted to emphasize a few subtleties that the book might not really emphasize, or that might just be easier to get from a video. So there's going to be three axes. So this one, traditionally we're going to put the x-axis coming out. We want to picture that as coming out of the paper. Of course we can't do that, but it's going to draw it in perspective. Here's the y-axis going this way and the z-axis going this way. And the thing I always tell my students is the goal here in any of our 3D graphs, or almost all of our 3D graphs, is to create a half-assed picture. Do not think you have to do it perfectly. Do not think it has to be wonderful. And do not think you have to have any artistic ability. I don't. And I can manage this, so you can too. So plotting points, we want to plot a point in here with some way of suggesting exactly what its x, y, and z coordinates are. Well, that's a little tricky because the same point, like this thing, I seem to be pointing at the origin here, but I could be pointing at something that's kind of above the origin, sort of towards the camera or even further from the camera. So that can be tricky, but one way to get around that is, for example, if the point P is, let's say, 2, 3, 1, I want a point that is 2 units in the x, 3 units in the y, and 1 unit in the z from the origin. Well, let's concentrate on the 2, 3 part. If I did 2, 3, 0, so let's mark off 2 ticks here and 3 somewhat equal ticks here, then I'm going to put dotted lines out to here, and then the key to this very, very primitive kind of perspective drawing is that this is the direction that's the x-axis direction, and so I just draw something parallel to that. I'm really drawing a parallelogram, literally, on the paper, and that's symbolizing a rectangle seen in perspective. So again, when I say perspective drawing, it sounds scary. It sounds like something from art class, which I always didn't do well at, but it just means draw parallel lines for us. Okay, it's a primitive kind of perspective drawing. So that's 2, 3, 0. That's not including the 1 yet. But then I just have to lift that up 1 unit. And we could be really careful when we can say mark off 1 unit here and then kind of bring it down. Well, let's just freehand something that looks like about 1 unit up. And that's going to be the point P. And you leave, and you could erase these dots to hide how you got that point, but it's often good to keep them as long as it doesn't make the picture too busy. That's going to be something we'll see throughout the course, which is sometimes you want more stuff, sometimes you do start erasing stuff because the picture just gets too busy and complicated. So that's an example. 2, 3, 1 is going to be 2 forward, 3 over the right, and 1 up. And if we really wanted to make it fancy, we could draw. There's various different ways we could have done that. We could have gone 1 up and then 3 over, and then 2 to the front. Or we could have gone 2 forward, or sorry, 1 up, 2 forward, and then over. Or we could have gone through the X and then up. And notice I've drawn a box, basically. And it was a terrible box because I didn't align it very well. But we could always, in theory, draw all these dotted lines so that this point is seen at the corner of a box whose opposite corner is at the origin. So that's one example of plotting a point. Let's just do one more. Let's say if we had Q, which was, let's say, 1, -1, -2. Now I've got it set up so that the first octant, it's not quadrants anymore, there's 8 of them. The first octant is facing us, which is fairly standard, although you can rotate things for convenience sometimes. And this is not in the first octant. This guy was in the first octant. This guy is not in the first octant. That's okay. It's just going to look a little bit different. So it's going to be 1 unit in the x direction, -1 in the y, so that's going to be sort of over to here. So it's a fairly small rectangle, drawn as a parallelogram again, and then down 2 units, somewhere around here. So Q is something around like that. Okay, so that's all I really wanted to say about plotting points, is this careful, systematic way of doing things if you want to be careful, and especially if you're new to it, to try to get a sense of where things are. And really, there's something very, very fundamental here. This idea of analyzing 3 dimensions by first projecting to 2 dimensions and then including the 3-dimensional later. That's an utterly fundamental thing of analyzing higher dimensions by projecting to lower dimensions. We're going to be doing that all the time, sometimes without hardly even knowing it. One other pitfall is, excuse me, plot. I know it's really really fun to listen to me cough here. Okay, it's not my day. I think that was a little bit of almond stuck in my throat, probably. Plotting lines or planes. The book does go into this, but I wanted to do my own example. Let's draw some more axes. And the tricky thing is, for example, if I say plot or graph y equals 1, I should probably go get some water. I don't know if there's a pause on this thing, though. That seems like, with our usual intuition, that seems like a line. Because I've told you I is equal to 1, and I haven't told you x. Well, in the xy plane, it would be this line, where x is anything and y is equal to 1. But that's not the situation we're in here. We're in 3 dimensions now. Y equals 1 implicitly means x and z are arbitrary. You've got to know the context, and our book does mention this very explicitly in one paragraph. I sound like a Grandpa Simpson or something. X and z, both x and z are arbitrary. If you know the context and you know you're in 3 dimensions, just because this z wasn't mentioned doesn't mean it doesn't exist. It means that it's anything. So y is definitely equal to 1. Let's plot all the points with y equal to 1 and x equal to anything, but with z equal to 0. Well, that would be this stuff parallel to the x-axis. And again, I just draw it parallel. And it's slanty on the picture, just like the x-axis is slanty. Excuse me. But z is arbitrary, so that means I can actually take this up any amount or down any amount. That's going to create a plane. Okay, so that is a plane. You might have thought it was going to be a line, but it's going to be a plane. And yes, I can't talk. I really don't want to have to redo this whole thing. One more example. And I'm running out of paper. Ooh, the Sharpie went through that thing, didn't it? Okay. I know I should redo it so it's perfect, but kind of in a hurry here. Okay. So for example, let's say x plus y equals 1. This one's actually harder than the previous example because you actually have to think about it a second to figure out what's going on. And as soon as you start thinking about it, you use your old experience, which is, oh, that's a line, it has slope -1, blah, 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 blah. But remember, z is arbitrary here. If I plotted this guy, x plus y equals 1 and z equals 0 in the xy plane, that 1 comma 0 and 0 comma 1 satisfy that. So it would be this line through here. But I can make z equals 5 minus 17 pi e whatever. And so again, it's going to be a plane, but now it's going to be kind of this plane diagonally cutting in front of the z-axis. Okay. And we're going to practice with how to draw planes better than that, although we're always going to look for a half-ass picture. But I wanted to go ahead and highlight that pitfall, that one equation is not going to be a line because it's one equation and 3 unknowns, not just one equation and 2 unknowns. Okay.